Hi, this is Mrs. Wiederholt, and welcome to my lesson video on inverse of exponential and logarithmic functions. Now let's get started. First, let's do a little review. What does inverse mean? For our purposes, it means to find the opposite. Graphically, it means a reflection. And this is where, we switch. If we have y equals, we switch the x and the y, and then we solve for y. I'm kind of getting ahead of myself. I'm starting to tell you the steps. But anyway, that's pretty much what inverse means. So what is the equation of the line that your inverse graphs reflect over? Well, it's y equals x. Remember, this is the parent linear function, and it is a diagonal line that goes through the origin of your coordinate grid. Now let's go over the steps for finding the inverse of an equation algebraically. Step number 1, change the f of x to y. Most of our functions or equations, they will start out with f of x equals. So to make it easier, we should change the f of x to a y. Step number 2, switch the x and y. And remember, this means literally just switch the x and the y, not anything else. And then the third step is to go ahead and solve for y. Now let's do some examples together. First, let's look at f of x equals the log of x minus 2. Now remember, if we do not see a base after our log, it means it is base 10. Okay, so step number 1 is to change the f of x to y. So we're going to have y equals the log of x minus 2. Step number 2 says to switch the x and y. So that's what I'm going to do now. So instead of y equals, it's going to be x equals. And instead of the log of x minus 2, it's going to be the log of y minus 2. Now the third step is to solve for y. Now I'm going to rearrange this because we are going to have to change this log into an exponential equation. And if you were one of my students, we did this with the x at the end of the equation instead of the beginning. So here's how I'm going to rearrange it. I'm going to start out with log, and I'm going to go ahead and show that base 10. So it's log base 10 of y minus 2 equals x. Now that we've done that, we can write this as an exponential equation. And we can do, for those of you who are my students, we said, okay, you take the base times times the exponent, and that's going to equal y minus 2. So it'll look like this. 10 to the x power is equal to y minus 2. Now do you notice that we almost have y all by itself? We almost have it isolated on one side of the equation. All we need to do now is add 2 to both sides of the equation. And when we do that, we will have 10 to the x power plus 2 equals y. Now all we need to do is write the answer in function notation. So instead of y equals, we're going to go back to f, and this time it's f of negative 1. That means the inverse of. Okay, so f to the negative 1 of x is equal to 10 to the x power plus 2. And again, this right here could be read as the inverse of f of x is equal to 10 to the x power plus 2. Now, why don't you try one? Now, I know it's going to be kind of difficult. Go ahead and pause the video and I want you to look at the one to the left. Look at the problem to the left and try to follow along step by step. And in just a moment, once you've done it, then push play again and you'll see if you got it right. Okay, now let's take a look and see how you did. Okay, step number 1, change the f of x to y. Change the f of x to y. Step number 2, switch the x and the y. Remember, it was y equals, now it's going to be x equals, and what? The log of, and instead of x plus 4, it's y plus 4. So we switched the x and the y. Step 3, go ahead and solve for y. Now right here is where I rewrote it so that it would be more familiar for us to try to change to an exponential function. The base 10 you don't have to show, but I'm doing that because we know that we need to have the base in our exponential. So I just rewrote it as log base 10 of y plus 4 equals x. And now to get my exponential function, I take the base, raise it to the exponent of x, raise it to the power of x, and that will equal y plus 4. And so here it is right here. 10 to the x power equals y plus 4. Now basically, remember at this step, you are just one step away from having y isolated. We just need to subtract 4 from both sides of the equation. And when we do that, we get 10 to the x power minus 4 equals y. And then all we have to do is rewrite it in function notation. And again, we would read this as the inverse of f of x. Sometimes you might hear us say f to the negative 1 power of x, but technically the correct way is to say the inverse of f of x is equal to 10 to the x power minus 4. Now we just found the inverse of a log function. Now we're going to find the inverse of an exponential function. So let's do that. Now let's find the inverse of f of x equals 10 to the x power plus 4. Step number 1 is to change the f of x to y. So here we go. I'm going to have y equals 10 to the x power plus 4. Step number 2 says to switch the x and the y. So I'm going to have x equals 10 to the y power plus 4. Now I'm going to have to change this to a log function, but before I do that, I need to get the base, that is 10 to the y power, by itself. So I need to go ahead and subtract 4 from each side. So when I do that, I'll have x minus 4 equals 10 to the y power. Now I'm going to rearrange this equation so that it's easier for us to get it into log function. So I'm going to write 10 to the y power is equal to x minus 4. Okay, so I'm going to have the log base 10. Now here's my base, and this is our argument, and it's going to be equal to y. So log base 10 of x minus 4 is equal to y. And voila, we have y isolated on one side of the equation. We have solved for y. So now all we have to do is rewrite this using function notation. So instead of y, I'm going to use f to the negative 1 of x, which means the inverse of f of x is equal to log base 10. Now in my final answer, since the base is 10, I don't have to put that base, of x minus 4. So here it is. The inverse of f of x is equal to the log of x minus 4. Now you try. I want you to pause this video and I want you to try finding the inverse of f of x equals 10 to the x power minus 7. Now let's see how you did. Okay, step number 1, change the f of x to y so that you have y equals 10 to the x power minus 7. Step number 2, you're going to switch the x and y so that it reads x equals 10 to the y power minus 7. Now you're ready to solve. Now before we can do that, we need to go ahead and add 7 to both sides so that you have x plus 7 equals 10 to the y power. What you did is just get the base all by itself. Now let's go ahead and rewrite it so that it's easier for us to put in log form. So I just moved this 10 to the y, put it in front, and move the x plus 7 and put it after the equation, after the equal sign. Now that we've done that, all you're ready to do is change it to log form. So you have log base 10 of x plus 7, which is equal to y. So log base 10 of x plus 7 is equal to y. You've isolated y, so now all you have to do is rewrite it in function notation form. So instead of y equals, it's going to be the inverse of f of x equals log of x plus 7. Remember, the base is 10, but since that's kind of like, I guess you would say, the parent base, we do not have to show that. Okay? Now let's try one more pair of examples. We're going to find the inverse of f of x equals 10 to the x plus 4 power minus 5. So step number 1 is change the f of x to y. So we will have y equals 10 to the x plus 4 power minus 5. Next, step number 2, we need to switch the x and y. So I will have x equals 10 to the y plus 4 power minus 5. Now we need to add 5 to both sides so that we have x plus 5 equals 10 to the y plus 4 power. Now let's rearrange it so it's easier for us to change to a log function. So we're going to put 10 to the y plus 4 in front of the equal sign and then x plus 5 after the equal sign. Now we can write this easily as a log function. So we will have the log base 10 of x plus 5 is equal to y plus 4. Now we're just one step away from having y isolated, and we just need to subtract 4 from both sides. Now we cannot subtract this 4 from the 5 because the 5 is a part of this binomial in the parentheses. So it will look like this. Log base 10 of x plus 5 minus 4 is equal to y. Now we just need to write this using function notation. So we will have the inverse of f of x is equal to the log of x plus 5 minus 4. For this last one, instead of you trying it by yourself, let's just go through it together because it is just a little different than the one we just did. We're starting out with a log function instead of an exponential function. So here we go. Step number 1 is to change the f of x to y. So we will have y equals the log of x plus 3 minus 2. And remember, this log is base 10. If you don't see a base, it is base 10. Now step number 2, we need to switch the x and the y. So this will be x equals the log of y plus 3 minus 2. Now in order for the log and the argument to be isolated on one side of the equation, we need to go ahead and add 2 to both sides. And so that will be x plus 2 is equal to the log of y plus 3. Now let's rewrite it so it'll be easier for us to put in exponential form. We will put the log, and I'm going to go ahead and show the base 10 now, of y plus 3 is equal to x plus 2. And remember, to change it to exponential, we'll take the base, and this will be the exponent, x plus 2, and that will equal the y plus 3. So it'll look like this. 10 to the x plus 2 power is equal to y plus 3. Now all we have to do is we need to subtract 3 from both sides. So I have 10 to the x plus 2 power minus 3 is equal to y. And now I just need to write it in function notation. So I have f to the negative 1 power of x, which means the inverse of f of x, is equal to 10 to the x plus 2 power minus 3. So there you go. I know this has been a pretty long video and really kind of an intense one. I do hope, however, that it has helped you to know how to find the inverse of exponential and log functions. And I look forward to working with you again. Bye-bye.